Okay, lesson 4.5 here is dilations. So the first vocab word is dilation, and that is a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation, and I'm going to do an arrow because we're going to go down to the next vocab word, scale factor, which is referred to as the letter K, which is the ratio of the lengths of corresponding sides of the image and the pre-image. The next word is enlargement. Okay, and enlargement happens when your scale factor K is bigger than 1. Okay, and obviously then the picture or object gets larger. I don't know what I was trying to spell there. Gets larger. Okay, a reduction then is whenever you have a value that is between 0 and 1. Okay, and that is when the picture or the object gets smaller. Okay, so a number between 0 and 1, you can think of like 0.5, 0.8, 0.1, or it could also be a fraction where the number that is on the top is smaller than the number that's on the bottom. So 1/2, 1/3, 2/4, 2/5, 2/8. Okay, all of those things, it could be whatever really, as long as the number on top is smaller than the number that is on the bottom. So then whenever you divide those numbers out, you get the 0 point whatever, okay? And then you know it's between 0 and 1. So if I'm looking at example 1 here, it says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. Okay, so we are going to find our scale factor K, and we are going to go C to P prime on top, okay, and over C to P. Okay, so you can think of that as your new over the old. Okay, so from C to P prime is 12, from C to P is 8. Okay, go ahead and I want you to reduce that down to tell me that that is 3/2. Okay, well 3/2 is a number that is bigger than 1. Okay, now if I look, yep, that makes sense because P and then P prime, it gets bigger, right? So it's an enlargement. Now if we go to part B here, same thing again, C to P prime over C to P. But this time C to P prime is only 18 and C to P is 30. So if I go from P to P prime, it's getting smaller. Okay, and if I reduce that down, divide by 6, you get 3/5. So that would be a reduction. Okay. In a dilation, C to P prime is 3 and CP is 12. Find the scale factor, then tell whether the dilation is a reduction or enlargement. So think the new one, so that the new always has the prime on it, goes on top. So C to P prime over C to P. Okay, and that is 3 over 12. Okay, those are both divisible by 3, so that becomes 1 over 4. So that would be a reduction. So you don't even need a picture to be able to tell what's happening. Okay, all right, next page of your notes. Okay, so the coordinate rule for a dilation then. So if P is at X comma Y is the pre-image of a point, then its image after dilation centered at the origin 0, 0 with scale factor K is the point P prime where it is Kx comma Ky. So we're going to multiply the X and the Y values. That means by whatever our scale factor is K. All right. So in example 2, it says graph triangle ABC with vertices of A at 2, 1. So remember, we need to label our points. B is at 4, 1. And C is at 4, -1. For our case, I hope this is getting bigger. I haven't looked yet because that's a pretty small triangle. All right, so it says, and its image after a dilation with a scale factor of 2. So yes, that number is bigger than 1, so it is going to get larger. Okay, so what I'm going to do then is I'm going to take my X comma Y and I'm going to make it 2X comma 2Y. Okay, I'm going to multiply all of those by 2. Okay, so that means that A prime, well, A was at 2, 1, so that means that that's going to become 4, 2. B prime, well, B was at 4, 1, multiplied by 2, so then I'm going to have to do 8, 2. C prime is at 4, -1, so that would be 8, -2. Now I'm going to go and graph those. Okay, so A prime is at 4, 2. B prime is at 8, 2. And C prime is at 8, -2. Okay, so you can see that it's the same shape, but it's no longer the same size. Okay, it got bigger. All right, example 3. Graph quadrilateral KLMN with vertices of K at -3, 6. L is at 0, 6. M is at 3, 3. And N is at -3, -3. Connect those to make your shape. Okay, and now this time your scale factor is 1/3. Okay, so again, we're going to take our X comma Y, and it's going to become 1/3 X comma 1/3 Y. When you multiply by a fraction that has a 1 in the numerator, meaning the 1 in the top of the fraction, it is the same thing as simply dividing by the number that is on the bottom. Okay, so since there is a 1 there, we can just divide every number there by 3. Okay, so K prime, divide both those by 3, and I'm going to get -1 comma 2. L prime, well, 0 divided by 3 is 0. 6 divided by 3 is 2. M prime, 3 divided by 3 is 1. 3 divided by 3 again is 1. N prime, -3 divided by 3 is -1, and -3 divided by -3 divided by 3 is -1 again. Okay, so then we're going to go graph those points. Okay, so K we said was at -1 comma 2, so it goes up 2. L prime is at 0, 2. M prime is at 1, 1. And N prime is at -1, -1. Okay, so again, you can see the same shape, but it's no longer the same size. It's gotten smaller. Okay, go to the next page. Okay, we are going to graph PQR on this first graph here on the left-hand side. So P is at -2, -1. Q is at -1, 0. And R is at 0, -1. Okay, and your scale factor is 4, so this is going to get larger. So P prime, -2 times 4 is -8. -1 times 4 is -4. Q prime, -1 times 4 is -4. 0 times 4 is 0. R prime, 0 times 4 is 0. -1 times 4 is -4. So -8, -4. Yeah, -8, -4. It's right here. Oh, sorry, that was P. What am I looking at? P prime. I wondered why something looked funny. Okay, Q then is at -4, 0. My bad. And R is at 0, -4. Connect those. And you can see that we have the same shape still, but no longer the same size. It's gotten bigger. Okay, now go over to this one. Okay, I'm just going to read off the directions and you can just watch my graph. So P is at 5, -5. So that would be right here. Q is at 10, -5. And R is at 10, +5. Okay, so then our scale factor, it says, is 0.4. Okay, well, you know that anything in the first column after the decimal is the same thing as being over 10. So you can think of this as being 4 over 10, which is the same thing as divided by 2 is 2 over 5. Okay, so now I'm going to teach you how to do this without using a calculator, because most of us would naturally go pick up a calculator, but whenever we go to take tests like the SAT, there are sections that do not have the calculator. You're not allowed to use one. Okay, so we need to get more comfortable with doing math like this in our heads. Okay, so whenever we have this, we are going to multiply by the number that is on top and then divide by the number that is on the bottom. Okay, so if I work through this here, I can kind of show you both here. So P prime then, 5 times 2 is 10. 10 divided by 5 is 2. So that would become -2 then. I already did the work for 5, so don't make it more difficult. Q, 10 times 2 is 20. 20 divided by 5 is 4. Okay, well, I already know that -5 is -2. So I already did that, save some time. Then R prime, I already found that 10 is 4, and I already found that 5 is +2. So then I'm done. Okay, so I only really had to mess with that twice. All right, so then I'm going to go graph those. 2, -2 is P prime. Q prime is at 4, -2, and R is at 4, +2. Make sure you're labeling them with primes on the second one, okay? And then the last one, example 4. Okay, graph triangle FGH with vertices of F at -4, -2. G is at -2, +4. And H is at -2, -2. Okay, so then it says, and its image after dilation with a scale factor of -1/2. Okay, so not only are you going to divide it by 2, but you're going to divide it by -2. So each one of those points you're going to divide by -2, and we're going to see what happens. Okay, we know that the 1/2 is going to make it smaller, but we've never dealt with this negative before. So let's see what happens. So f prime, -4 divided by -2 is +2. -2 divided by -2 is +1. G prime, -2, we said was just 1. 4 is going to be the opposite, so that would be -2. -2, we already said comes out to be 1, so H prime is going to be at 1, 1. So now let's go graph those. F is at 2, 1. G is at 1, -2. And H is at 1, 1. Okay, labeling those with primes. Well, now I can see it got smaller because of the 1/2, but then the negative made it flip over. Okay, it was basically like a reflection. Okay, that is it for today's notes.